Hi, this is Coffee Compiler Club. Anything and everything to do with compilers and language runtime and garbage collection and performance and nil and not the nil. And every other person on here is doing their own favorite language hack. It's all good. You're being recorded. You show up on YouTube within a couple hours. That's it. And we have one new person who I'm going to immediately ask for the 10-second, why are you here thing. And then we'll pick it out from there. Yeah.
Okay. Should I?
Yeah, do it.
Okay. I'm a PhD student in Sweden I'm working with programming languages, so I'm really interested to hear like your insights about compiler development.
There you go. Sounds good.
What's your favorite topic about compilers class?
Right now, maybe like type systems is the most interesting to me, but I'm also interested in like maybe running languages in a distributed environment. My supervisor worked on a language called Oz, like the Wizard of Oz. But it's an old language, so yeah.
Cool.
Okay. I will ask you one question. What is a type to you, class?
Like, how do you mean? At a deep level or like a personal level?
Your impression, your understanding.
I like types, but I don't like typing the types.
No, what is a type?
Oh, like a set of values, maybe.
Like one of the two common answers.
Yeah. Okay.
The other one is a set of things you can do, a set of operations you can do to something.
Okay.
It's not an easy answer.
Yes, no obvious easy answer. It kind of varies. I mostly go with the values side. I think Cameron mostly goes with the set of things you can do side. And they both work, just a different way of viewing the problem.
You can also view it as just a set of properties.
Yeah, that's what Cameron goes for. Yeah, set of properties.
The most common is a set of properties of program that can contain values. That's the most common thing I pick up in the books.
So, do you prefer statically typed or dynamically typed?
We're all statically typed people here.
We're a static camp.
We shoot the dynamic people in the foot all the time.
We're the static camp.
We're a static people.
Types have no value.
There you go. That's what's the Lisp programmers know the value of everything and the cost of nothing, something like that. Yeah, exactly. That's right. All right, I'll do my 10-second AA update, and then somebody else has to have a question for the audience, including Klaus, who has lots of questions already, obviously. So, I've kind of crossed some threshold, and more tests are working faster and faster. So, I'm getting there. I have a, main code base, and I haven't pushed back to the main code base. This is all in TV3, Prims2, whatever branch. But I'll probably push this next week, maybe even this weekend. And that will be a point where I can run things. Here's more people. Run more stuff and type more stuff in the in the main code base. Where did I lose Dan? There he is. And I say this for Klaus's benefit. I'm using a Hindley-Milner for type inferencing that I've turned into an incremental work list algorithm, turned into a monotone analysis framework. And I'm combining it with several other monotone analysis frameworks to type programs that you can't type with Hindley-Milner style typing alone, or with C Java style forward flow typing alone. So I have a provably larger set of things I can type. I don't know if it's an excitingly larger set. I can have demos that show it, but I don't know if it's exciting. And that's, you know, mostly for me, it's an incremental work list algorithm for Hindley-Milner turned into a monotone analysis framework is sort of like really cool. And then after that, there's a lot more. Once you have a monotone analysis framework, you can pile on lots of other stuff. So I have call graph, incremental call graphs getting built. And dead code doesn't have a type in Hindley-Milner, so you can have if false code that won't screw up your unification process. It'll remain outside the typings. And that's for people who do like if def Windows, else if OS X, else if Linux, else if whatever, can have calls with wrong argument counts and broken things in the turned off code, and it all just works. That's probably enough of that, unless somebody wants to go down the latest du jour on what the hell AA is doing. But if somebody else has something they want to bring up.
Well, I'm just curious what for AA, are you doing backend code gen, or you're still at an interpreted level, or?
None of the above. I'm doing typing. First, I have to have a semantics, and then I can have execution.
Oh, okay. I thought when you said things were moving rapidly forward.
Yeah, no, it's gone from, I've been down the typing realm for like 2.5 years. I'm hoping it's settling down.
I'm surprised you're still a proponent of typing.
Matter.
2.5 years working on it.
Well, I lived with many other programming languages for which there was a known assumed this is what the types meant. That turned out to be, you know, junk. And then the optimizer pops up and says, oh, haha, look at this cool thing I can do. And you get all these things in C, of course, with the undefined behavior things, right? Yeah. And then I've pulled some examples out of what a nice, well-running optimizer would do to somebody's program with undefined behavior. And it gets really ugly really quick. And then it turns out that there's actually something people expect that's not formalized, and you had to match that behavior. And so when I came to Java, it was very exciting to discover that they had kind of formally nailed down lots and lots of behaviors. And I didn't have to deal with the magical, oops, no one told you what to do here. So I did something, and it wasn't what anyone expected. So then I got told to try something else, you know, kind of thing, right? So that got better. I've always been a proponent of typing. You know, I've used untyped languages, and I've used type. And as soon as you get past a certain point, you want types.
So I think it's a pure form of programming language design. You don't even need to execute it. Just figure out the semantics. Just
exactly.
Get rid of everything unnecessary.
Well, it's because I keep flipping around sort of internal representation in order to get the types correct. I have a strong notion of what the language looks like and how it'll execute. And I know I can boil it all down to like bare metal. That's one of the hard design goals. But the actual moment by moment, how like there's an operational execution engine that I've been working my way through that I know I can boil down to, you know, bare metal, and also I can do, you know, the strong Hindley-Milner type inferencing style algorithms on it, both. So that's taken me a while to get all the corner cases knocked out, and there's more corners to get knocked, I'm sure. But that's what the big stall was about, was what's the operational execution model that I know I can boil it down to metal. And then you can go down that path if you want. It's a little different, but not hugely different than what people are used to. Mostly having to do with closures and frames. Explicitly pass in your closure, your stack frames, your environment, knowing full well that if you're stack-like, I can boil it all the way into a stack, and it'll just fold up into fast-running, you know, stack-allocated code. But if you do an upwards exposed funard, you escape something, you'll get a heap allocation out of that, and then I can detect that at typing time and tell you at typing time that you're about to do something that's very expensive, and you have to ask permission or tell the compiler permission. You have to say, don't go fast here, go easy, or whatever.
What would be the default behavior, to run fast or to?
I will probably break out a bunch of things, and the default will be easy, and I'll ask for fast. But easy probably will not include upwards exposed funargs. You'll have to have another type parameter on that says, and here I'm doing a stack frame that's getting allocated, so I need a stack frame no more. And did you really intend? Because that one's a little more, in my head, that's a little more unusual that people actually want to do that. You're making a generator, you've got some sort of built-in, stream that you're yielding continuous results on, or whatever. It's a more unusual pattern. So ask it, because if you did it by accident, you probably didn't mean to.
So the compiler will resort to the efficient version of the code.
No, it'll resort to easy, which will allow auto boxing, and it will allow garbage collection in general.
So you have to ask for the fast version.
And you have to ask for fast, yeah. And fast will turn off auto boxing. And I'll probably not yet. I don't have that type worked out. But I'll probably go to a rusty flavored allocation meme, idiom, whatever, in the fast code. And if you want garbage collection mixed in, you'll have to go back to saying, I want GC and otherwise fast. Because generally, if you do a lot of GC, your code ain't fast no more. You run it. It's one of those things you run out of bandwidth really quick if you're just
is fast mode basically sort of annotation on a type?
Yeah.
And it meets with other things?
Yeah, right now it's a lexical, not type, it's lexically scoped. So fast code can call fast code, but if fast code calls easy code, you'll throw an error. And you can excuse it and say, and here I'm going to say, like, I happen to know that this is a rare case and it's complicated, so I'll let it be easy and do stuff, but it's not my comment, and the compiler doesn't know your profile heuristics, so it can't tell that this is intended to be a one-off, unusual.
So effectively, you can have a fast scope in an easy scope in a fast scope in an easy scope.
Yeah. That's the design plan, and none of that's actually there because first I wanted to get my type inferencing done, because all of that turns into how do you infer a reasonable result. So I can turn around and say, you then, like when I say you've asked for fast and I say no auto boxing, you of course can auto box if I can unwind it. Right now, if I just unwind it in the typing, not in the optimizer, there's a weird subtle difference there. If I unwind it, then it's okay, right? It's easy-ish coding style and fast code because there was no auto boxing at the typing time. So it's whatever the typer figures out. And he has to have a no heuristics. He has to have a hard, this is what I do. And then it goes so far and no further, so that the same program and the same kind of direction and space everywhere always comes with the same answer for what the difference between fast and easy is. And then the optimizer does a best effort after that. And the optimizer might in fact take, auto boxed code and unwind it, and because he's inlined like the hell and gone, or he does profile based things and discovers the 99.9% case is, no allocation, no auto boxing or whatever. There's all kinds of things optimizer will do that the typer won't. So fast and easy, cool idea in my head, not implemented. It's on my to-do list right behind getting the last bits of my type inferencing sorted out. So along that, I thought about more. One of the things I've also done is I've got Henley Milner on SSA form. And that's very, very unusual, dear as I can tell. Part of making it a monotone analysis framework. All right, somebody else's turn. Well, I'll make you do it, Derek. What's your update?
Okay, so this is a thing that I've been struggling a little bit with, and sort of just let it fester without trying to fix it, which is I have places in my system where my data type needs to be a byte, and other places where it can be 32-bit like long, and then it can be signed or unsigned. And so I've been using range types for this, and the problem that I run into is when I need to widen, and I can't figure out when I need to widen to a byte and when I need to widen to a long, and then also sometimes I'm not sure if I should be widening to a signed or unsigned version. So I'm
When do you have a widened question?
well, so pretty much just when I've got a loop and I'm counting through a fee or something like
Yeah, you
that.
have a fee. Yeah.
Yeah.
You widen ranges the way you obviously widen range.
Yeah.
Are you're doing like my hotspot flavored widening range types,
Yeah.
right? Yeah, you just do a standard widening thing, except that you have to have a, oh, York's having failures come in too. You have to have a widening count before you blow
Yeah, I
out.
do that. So I get to the point where I need to widen, and then
Yeah.
I'm not sure which version which type I should widen to. So
No.
sometimes I think, should I widen to a
No,
byte,
no,
or should I?
This is a there's this is a hard answered thing, or what? Not hard answer. There's a fixed answer. There's no heuristic guessing here. You should have a hard answer in your face. So if you're mixing two ranges and they are not exactly the same, you take the wider of the two for the min and the max, right? That doesn't count as a I'm sorry, that counts as a widening step. If you've widened more times than necessary, than you want to, then you need to ask the program, what's the next layer up of widening? That does not count against your widen counts. That says, I took you to the largest I can do. That is the minimum of all the possible types in my face, the ints I'm looking at. Now I widen again, but I wanted to do that widen with the program told me it's this much bigger. So I have a count from 0 to 1, 0 to 2, 0 to 3, 0 to 4. Okay, wait. What's the largest I can go to that doesn't change any representation? 0 to 127. Okay, I'll jump to there and reset my widen count. Now, if I widen again, the program tells me that it never gets to 127, or it tells me it goes to -1, or it tells me it goes to 128. And in that case, I get told I need to be unsigned 128 or signed, right? And then I can reset my count again, and now I can range up in the next larger size. But when I hit an edge,
I see.
I
Okay,
get told.
yeah, that makes sense. So you basically, yeah, you just sort of go step by step through your types.
Yeah, right. Yeah. And you get told every time, if I present you with an int 8 and you tell me there's -1 possible, I have to go to, or an uint 8, whatever, and I get told -1, or I get told, 1000, okay, I need to go to U16, whatever. But every time I step up a layer of bit representation, ask the program directly.
So you're not just widening right to the widest type.
No. In hotspot, I didn't have this problem because there was no byte short int issue. So that one I just went straight to the max size straight up.
Yeah.
So what do you do with x++ in a loop of indeterminate number of loops?
Yeah, exactly. No, that says that you're taking whatever the initial x is, which if it's negative, you went sign, but if it was 0, you went sign. And you bump it once and you 128 and you go again. Oh, now you're 256. So you run it, you go to 257. Oh, now you're 16 bits. So you go to 16 bits plus 1 overflows, and you pretty quickly hit int 64 and you're done.
Why stop it in 64? You go to infinity.
You pick what you're going to use there. So if you want to represent big ints, you go to a big int and you say it's infinite. Now you've closed now you hit a fixed point. Right. You can hit a fixed point. You decide what you're going to, hop out at.
Yeah. For me, my biggest representation is 32-bit. Ints.
Yeah.
So
right.
Yeah. Okay. That makes sense. Yeah. So I should forget about the heuristic guessing and
This is not a hit.
I was even trying to do something where I was trying to pass in the bounds, and then a lot of times I couldn't figure out what the bounds would be, and so
right. There are things you can do if you know bounds, but you can represent them as a cast, and then it turns into a join in the lattice.
Yeah. And
that you can still then be monotonic and hit a fixed point with a join in the lattice.
So when you run into casts, say I've got a range that's stable, so we're not in this loop, and it's like -1 to 2, say. So it's just a short range.
Yeah.
And then it gets cast to unsigned.
Right.
So do you just say, maybe this is a bad example because this is practically the whole range.
No, it's fine. Do a join in the
But-
lattice.
So do you just say, okay, this is the full width, or do you try and figure out how the bits would come out?
I said it twice. I'll say it again. You do a join in the lattice. The cast has an unsigned. That's a 0 to infinite range. You join it, not meet it, with -2 to -1 to +2. Immediately it goes to 0 to 2. That's what the join will do there. You throw away the -1.
Oh yeah, but wouldn't a cast of
The cast
would a
is
cast
in
of -1 go to 0, or would it go to?
You've just told me
like
that -1 is not an option. That's what the join in the lattice is doing.
Yeah. Okay, I was thinking that you'd keep the bits, so you'd end up with 255 or something.
You join, which will be I mean, I do it with dual, meet dual, but effectively it'll take the intersection instead of the union of the range. For a range, it'll do an intersection.
So a cast is a join instead
Just
of
a join in the lattice.
Oh, okay. I had this whole logic about figuring
hear
out what the bits would mean once you change
Yeah.
how you think of the signedness.
There's this whole dual side of the lattice that people who don't mess with it a bunch get confused. And especially I want to say when I try talking to like functional theory guys, not to say classes group or anything, but people from that side of the universe didn't understand what you could do with the duals and thought they were useless, but they didn't understand it. And it's a cast. And it's every time you know something because you ran an if test. If not null, I cast. But if I do if type, I cast. And then the else can have the opposite cast if I have a sharp enough representation to have that present. And then the cast turns into a join, and then it's all monotonic, and you have a fixed point solution, and everything works out fine and dandy, and you get your good answer.
Yeah. Okay. I have to play with it. I mean, I've got my joins and stuff all working, but I haven't done the optimistic typing stuff, so I've barely used any of that stuff so far.
Yeah. Well, the join will show up in not being optimistic yet, just straight up. You do an if test. If x greater than or equals 0, cast x to be a positive range, and you'll get the join effect.
This actually gets me to the next question that I had, which is I couldn't, well, right now I do an if test like that. The information that should be there isn't going into my
okay.
X, the X. So so that needs to be part of it. It's a little unclear to me where that goes actually.
Okay. So I make a cast node, a node in the graph. It has a control edge because it's dependent upon the if test. It has a type that I pull from the if expression. So I look at the if expression and I'm limited to if expressions of a particular simple kind.
So this is when you're building the graph.
Yes. When I'm building the graph.
Yeah, okay.
I see if variable name in simple expression, then I put a cast on the true arm to the, the lifted variant, or the false arm I can do as well in some cases.
Okay.
But if you had
I don't know why it didn't occur to me to do that. So I was trying to think, I can infer that there would be this change when I'm okay. So it's a cast node that I should be inserting.
It's a cast node, it's control dependent, it has the constant from the test. It replaces uses of x. So if you say if x greater than or equals 0, when the true side you put in all uses of x are usually the cast of x to a positive. On the else side, all uses of x use cast of x to the negative.
Right. And this would probably stop all of my loops from widening out to full width.
If you have a cast on the exit condition.
Yeah, because my loops.
Usually cast on the exit condition is X less than max, but max has no known upper bound. If your max is always 10 or a constant, it's going to work.
Yeah.
But it's not symbolic, and there's no symbolic math going on here. So X less than max doesn't.
Well, my problem was that, I have the fee and the data flow path that becomes circular inside the loop, and I have the increment, but there's nothing about the test inside there. So every loop would end up widening to, full width, right? So I'd have like a for X equals 1 to 10 type of loop, and it would get typed X as, full width every time.
So 1 to 10 you get with the cast. That's right.
You get it with the cast. Yeah.
You get the cast. Yeah.
That was the missing thing there.
I would say that actually both approaches are reasonable to representing and like figuring out this extra information. One of the approaches is, you don't have any special, you don't convert this value into this node, but in your analysis, you analyze dominating checks and figure out constraints from that. And actually, that's what we do in our LLVM-based compiler.
C2 puts the check in, the cast in, but he walks the dominating tree looking for identical tests. But if you put the cast in and you have a series of tests, the casts accumulate in the typing system directly, and you get the same effect.
Yeah, they are equivalent. So the alternative way is you kind of cache the result of this lookup in the IR. And this is called, I've seen it called SSI form, static single information, where you discover new facts, you rename the value. Like you have a new value with information. So I play with this idea in our compiler. So my motivation was that it would save some compile time, so you don't need to walk the DOM tree all the time. But it didn't interact nicely with other LLVM analysis and stuff. Like you're just introducing some extra node that you need to teach other analysis and tasks to look through if they want to figure out something about.
That's LLVM though. All right. So what I just heard you say on that is you get that straight out of the sequence of casts in a type analysis without any further ado. It has identical knowledge gathering power.
Well, but then sometimes you need to know that this cast node is actually exactly the same value as something before. And now you need to have your rest of the optimizer know this fact that they can actually, that other analysis can look through this cast node and figure out what the underlying value is.
You're talking, okay, so that's all right, fine. Yeah, so there is a thing where if I'm looking backwards through a sequence of nodes to find something, if I see a cast, then I know it didn't change the value, but it did change my knowledge of the value.
Yeah, so you need to have this plumbing throughout your optimizer, that this is a special node and you can look through them to actually see the underlying value.
C2 did a couple times of that. I haven't needed to do that in AA. Like the number of times I had to do that or found that interesting to do that in C2 was there, but it was very limited. I should go look and see if I have how many times I peek through a cast.
So I think effectively this is a way to cache this information in the IR. So functionally, it is equivalent to just walking the DOM tree when you're looking for the fact.
No, it's not even that. I'm saying you get it straight out of forward flow typing information. You don't have to walk to get the facts.
Wait. What I'm saying is that it is equivalent. Like the facts you get would be
equivalent. Yes, are equivalent to walking the DOM tree. Yes.
In the end, you can get to the same information just in different ways, either by walking the DOM tree or by caching this in the IR.
It comes cached at every node as part of the normal forward flow typing.
Yeah, basically that cast is just caching that information in the node, like adding that cast node would, because I was the convoluted way that I was thinking about doing this, and I hadn't done it yet, would be to say, oh, there's a fee. I'm going to look at the region that it's in. Is it tied to an if? If it is there a test?
Yeah.
And then is that test looking at the thing that I'm looking at? And if it is, then I can narrow the type or something.
Yeah.
I like the idea of caching the information in Node a lot more because that seems a lot less painful and brittle.
Okay, fine. It worked out for me. The thing I'm trying to think of places where I would want to peek through the cast and C2. probably there's a game where you have a fee of a cast value that is not, that just points to itself in a loop. You're just carrying a value through somewhere in the body. You've if tested. If you failed, you went off to die land. If you succeeded, you looped again, and you kept the knowledge after the first if test. But the fee actually didn't change anything. It was the same value, and you'd like to get rid of the fee altogether. And which means the test is actually loop invariant now that I've said that, and you'd rather hoist the test out of the loop anyhow. That's probably why that one wasn't. I don't know which way I peek through casts. I remember, Arthur, I do remember peeking through casts from time to time. I probably remember what they were for.
Yeah, and actually, I never actually implemented this or prototyped this scheme. It's more like, okay, I would need to. There will be this kind of interaction with the other parts of the optimizer, and I just never. I could never convince myself that it's worth like going for this.
Yeah, the peek in C2 is a lot cheaper and only happens in a handful of places as opposed to the way LLVM's set up. His IR manipulations are different.
Yeah, so I think both options are reasonable, has their own pros and cons.
Well, if you keep talking long enough, I'm going to pull up the damn code and take a look. Somebody else should say something because this will.
So so I don't have to spend much time figuring this out. If I'm doing a cast and say the value is X is less than 10, then I want to say join, and it would be the min value of a full range thing up till 10 would be what I'm joining against.
If you have the test X less than 10, then you have a negative infinity to 10.
Yeah.
Right. And now you do a join.
No.
Yeah. And it works for not null versus nullness, and it works for ranges, and it works for subtyping, and
yeah. Okay.
And because it's a join, you get if this is a lattice join, you get a fixed point out of the answer too.
Yeah.
You keep your hard guarantees.
Yeah. Okay. Great.
I have a couple places where I peek through. Now those don't count. That's all there are. Okay, so that's showing up in like something around inline vcalls where I'm casting this pointer. It's showing up a little bit in escape analysis. There are a couple library calls that peek through. That's mostly it.
I would think like every time you need to know what the value is. Let's say you need to know whether the value is an argument or not. You need to look through this. You want to know whether the argument is, I don't know, new allocation, something that you know about, like you know about the value just based on the value.
Well, yeah, you peek through is a one step, and that only goes so far. If you have an endless peek through setup, you get a different thing. I mean, I'll look at the cast things for a second here. They're expecting a pattern that has a cast because they're taking raw memory and turning it into an object. And oh, this is just a fucking assert. Let me find something else here. Here is a pattern which includes a control flow diamond where somebody on one arm says, I've cast it, and then I do something on the other arm. I didn't, I just skipped around it. And when I came back out of the cast, it was equal on the other, both arms are the same thing. So it's skipping through a control flow diamond. I think that would be a reasonable thing if I'm looking for, like I'm looking for the root source of an allocation, and I have a couple diamonds where I subtype and or null check and come back and null check and come back. And I'm trying to, that's a walk the dominator tree and skipping the casts to verify that I get the same value when I'm trying to find where root came from for escape analysis.
Yeah, and like I don't know, maybe there is not that many places of like like this in C2, but I can imagine a lot of like everywhere where I want to see the underlying value, I would like want to.
But you get the type of the underlying value, including the sharper range analysis, but you don't get like the source where it came from. Yeah.
So all trade-offs as usual.
I do know that like fees of casts in the same thing fold up. That's a standard pattern. But saying I merge the sharper and the weaker version, and you just get rid of those. But that doesn't help if you have to go up a chain of casts to find a root place. So there you go. Yeah. Mostly I found the casts useful around around null checks, around subtypes. I do it for integer ranges. There's a handful of people who got excited about integer ranges. Actually, the stupid integer range one kept showing up in the network byte buffer code, where known fixed ranges were being used for like, I don't know what, reverse bytes for 4-byte quantities flipped, and you had to do range checks from 0 through 3 or something stupid. There were a bunch of stupid minor places that were hot that you wanted the integer version of the sharpening. And I didn't have, Derek, I don't have your issue in the Java. I don't have your issue where I have to do like a bytes versus whatever. The Java virtual machine integer math is always done at 64 bits and then chopped back when you store it down. But the range checks cared.
Yeah. I'm not sure if some of these things, I'm also not sure if they'll really show up in real code or if they're just sort of pathological examples that I've managed to come up with.
Yeah, so that's a premature optimization, which goes both ways. I've done it where this looks stupid, I should fix this now, and then of course no one cared, right? And then there's ones where this looks stupid, and if I don't fix it, I have to implement the code generation for it. But if I just wipe it out in the optimizer, it never gets to code gen, and I'll deal with it later. Somebody will have a version that'll get to code gen, and I'll have to fix it there, but not right now.
Yeah.
But yeah, I've done plenty of premature optimization.
Yeah. Well, so
like that time you saved 2 weeks by not doing tail calls in the JVM.
Yeah, exactly. There you go. Sun was headed down the meltdown. I had a lot of things to do with and never mind. That's a painful, nasty story.
It's open source. Anybody here can add it, right?
That's correct. 25 years later, it hasn't been done. Suck. Fine. No calls. I'll put them in the AA this go around. All right, somebody else's turn.
I was listening last week as we were having this discussion of like, what is a character? And that you might want to have multiple different views over the same set of bytes. And I was wondering just more generally how people think about iterating over bytes. Because if I have a stream that's, say, var int encoded deltas of integers, but I want to be able to write a simple for loop over it that operates on the integers, how should I structure that iterator over a sequence of bytes where I'm not making a giant object that is all of those bytes having been turned into just integers?
Well, I did this in H2O all the time. I can tell you what I did there if you're interested, but it was pretty. I mean,
like, did those loops look like normal Java loops, or
they were normal loops? They both looked like and were, and the accessor for the array sucked. So you used round parens instead of square brackets when you access the array element.
And so I mean, you see this all the time with like run length encoded data or delta offset encoded integers, or so I mean, which you would have hit in H2O all the time.
So you just make a thing that is a view over it and keep calling next, or
no. I said I was handed a thing I called a chunk, but it's a chunk of an array, and I said for I equals 0, I less than chunk.max, I plus plus, chunk at round parens I. And then that chunk iterator dealt with under the hood what it needed to do. If it was not a run length encoding, it usually just did a shift scale add on I, depending on the compression of the moment. If it was run length encoding, you had to keep a current index internally. So chunks had a one-off current index, and you didn't.
So what happens if I pass in an I that's not consecutive? You had to like run forward or rewind, or
yes.
Like if the last thing I passed in was I equals 7, and the next thing I passed in is I equals 27.
I totally looked and said the last was equal to 1 minus the or whatever. My cursor is correct. I hand you the next element and bump the internal counting. If they don't match, I recounted from start. And the point here was that the way that you wrote the code, the 99% way you wrote the code, was that you said for I equals 0, I less than max, I plus plus, stream through it. And everyone understands the streaming model, and they're all writing the code that way. And the hardware understands the streaming model, and the performance all is like maxed out. Okay, but you can go pick a random element out of the middle if you want to. And that's not super fast, but that's super rare. So I don't care.
So if I'm making the strings API for my language,
this
and now someone says, give me the character at 47.
Yeah, if you have it in a
does that mean all of my strings have just become mutable because they're essentially keeping this like cache inside them of the current cursor?
If you're so for me in the land of H2O, chunks were handed out to a single thread at a time, so they could manage one cursor at a time, and that was fine. If you're going to have multiple guys running over a string, which internally is actually running a count because you've got Unicode, then you have to do something different. You have to move that internal counting out, and it becomes a much more complicated model. So
Aaron's question is kind of like, if you can't see the mutability, is it mutable? And my answer is no. If you can't see the mutability, then it's an immutable data structure. It just happens to be changing inside.
Right, but if I say char at, I've just caused an allocation because that counter has to live somewhere.
Yeah, exactly. This is my.
I mean, maybe that can live on the stack inside of whatever whatever function I'm currently calling, but
yeah, this is my strong recommendation that if you want performance, you don't do that. And if you want to have some sort of convenience for people who have, funny umlauts in their languages, or go to whatever, then you're either going to suck on performance, or you're going to demand an allocation, which is its own suck on performance, but maybe it's not the worst case scenario. You need to pass in an external dude. So I talked to that stupid database company. They weren't stupid. They had some bright ideas, but not one of the bright ideas was grabbing the default strings out of Julia, which were Unicode enabled, which made every string car out have an internal loop to go count on things. And your database company doing TCP/H queries with old school ASCII strings as a major part of your business model and performance metrics. This was like directly orthogonal, like performance wise, like shoot yourself in the foot harder, can you please? I mean, I don't understand how you could shoot yourself in the foot harder. So I went through and replumbed in standard byte array flavored strings in a bunch of places. And lo and behold, there's like fucking 10x speed up numbers, like huge speed up numbers for getting rid of that nested string looping on every possible string thing you did. So go careful here. There be dragons if you care about performance.
Right. Because you want your string interface or your packed delta encoded var int array, like whatever, to be able to have multiple views where I can say, give me byte at, give me integer at, give me glyph at.
Right. People have this old school knowledge of strings as an array of bytes. So you want to have that view. And that's the high performance view. And it covers a lot of ground. Then there's the glyph at view, which I claim is much less common and makes somebody ask for it specially. In the asking, they get an allocation, which allows them to account a cursor, which gives them a reasonable performance if they're just walking through it.
So just to be clear, you're skipping a big important in between on those two, because you've got the byte at, which is great for ASCII, so your 7-bit character sets, which is
it's 8-bit.
7-bit character, 7-bit character sets.
No. I said ASCII, but UTF-8.
Oh no, but UTF-8 is different. That's what I was going to say. That's
Okay.
the one that's in between, right?
Yes.
So because you have bytes,
iterating
you
glyphs
have
is different
code
than iterating
points,
code
and you have
points is
glyphs.
different than
Yeah.
iterating bytes.
Yes, I'm
That's what I
saying
was trying
have
to
a
say.
byte iterator which gives you an unsigned 8. Not necessarily an unsigned 7, gives you an unsigned 8. That's great. Now you want a different iterator for glyphs versus I don't care what code points.
But I guess I'm trying to sort out the advice, because the advice you gave with H2O was never decode your ints except in registers.
That's for big data. High
And the advice you gave
performance
for the
streaming.
database company is for your strings, treat them as bytes. Don't do this variable length encoding game at all. Like, would
Yeah.
having used a good cursor system over their strings have solved their problem in much the same way that saying, no, we're going to treat it as bytes solved their problem?
No, because they don't have any purpose for a glyph view. They're holding bytes that are not interpreted except in queries. And unless their query includes glyphs, they have no care for a glyph view over strings.
But it was the fact they were going n squared that was crushing them from.
No, it wasn't in square. It was a nested loop. If I say, give me the car at whatever, 17, instead of adding 17, he looked for the start of a code pointer thing and then would spin counts on it. And the issue is that query had no glyphs, and the code he was looking at had no glyphs. And the query had no glyphs, but he didn't care about glyphs in the code he was looking at because he wasn't going to treat them like a glyph. The query was really, give me this set of bytes. Find a match for this set of bytes in this string. No glyphs in the query. I don't care about glyphs because I'm matching on bytes. But the default string manipulators in Julia said, I'm going to treat it like glyphs all the way down the line. And therefore, I took the doubly nested loop every time. Now, the doubly nested loop only counted straight through, but the fact that you had an extra loop nest, even if it just bumped one and then came out and bumped one and came out, added so much overhead that I got giant speed up factors by getting rid of it.
So it wasn't that they were saying, give me 17, and it went from 0 to 17, and then they said, give me 18, it went from 0 to 18. And
No, they
said, "Give me
were.
19,
No,
give me
that
0
was
to
going
19."
on as well, because Julia didn't have any way to go to 17 without having an incrementer, and they had some variations of loops that would give them an incrementer that would do the cursor management. But it wasn't like baked in for the default or whatever. It wasn't a sensible, you could get it just by writing code.
Right,
I'm writing
so
a border
that's the
word.
heart of my question is,
Yes.
right now you're designing a language. You've
Yes.
been in Java where you had to think
Yes.
about the cursor
Yes.
and essentially design a cursor system.
Yes.
What do you put in a language to make it so that I can give you an API where a
That's
developer
easy.
who's not thinking about cursors for things like strings
Yeah.
accidentally gets a healthy behavior when they're just like,
Right.
hey, 4-thing in
Right.
string.
The language will provide no cursors and assume no need for a cursor. And the libraries, the standard libraries, will hand you cursor things. Here's a pile of bytes. View it as a pile of strings, as a string thing, right? That will have the no overhead array of bytes version of a string, but the string-like API. So it's an ASCII or UTF-8 string-like API. Then there's the same one that says Unicode string. Here's a pile of bytes. It maintains an internal cursor. If you ask for incremental, you get speed. If you ask for random access, you don't. The cost model changed. You got told that because you said uString instead of string when you went and said something about it. And that they can be over the same pile of bytes. It gives you a different view either way. But someone said for I equals 1 to string.length, and somebody said for I equals 1 is uString.length, I++, you got a different one at the act of saying, give me a uString versus give me a string.
And hopefully there's a convenient way to pass those around. If I have some standard library function and I pass in a string, or I pass in a slice that's in the middle of a string.
Yeah, somewhere in the world, there's
you want those to
right.
behave similarly, despite the fact that the sort of memory object I gave you in one was a whole string, and the memory object I gave you in the other is start and stop pointers, and then
probably I'll
base
hand
to
you
an alloc thing.
I'll hand you the fast version by default, and it will be baked in, and you can have a view over the fast version that gives you the Unicode version.
And better be mutable.
Well, the Unicode version will have a cursor that is not visible. So it has no side effects except performance. The mutation you get is you can screw your performance.
We'll get a reference to the underlying array.
Yeah, but it doesn't, if you're doing a string, I'm assuming you're doing an immutable string, you get reference to the underlying array, you can't mutate it. The underlying array itself will not be mutable unless you've done, a breaking thing already. And, I do those things all the time, and I know other people who would, and that's okay. But if I ask for an immutable whatever, I'm going to get an immutable whatever. And if my viewer has a cursor that mutates internally, but I can't tell except for performance, I still say that's immutable.
So what protects your APIs from needing to think about the distinction of, oh, did you hand me a base array thing, or did you hand me a slice over that array, or did you hand me an iterator over that array?
I don't know. I took a string-like thing. If I'm doing, one kind of string-like thing and get handed another, I probably end up having to do a vcall somewhere on the string-like thing to get to the other version. This is library design that I haven't put 2 cents in my head on, knowing that I want to make sure the default thing is sort of sane and fast, and you can ask for more fancier versions that are slower, and there'll be a big flag in the docs saying, and this version loses the constant time cost model. Random access is no longer.
I was thinking about Python. I will often call Python libraries and be like, here's my string bracket from this character to that character. And I frequently pass slices of strings into things.
Okay.
And those slices of strings have the same API as strings, so it's very convenient.
Right.
Python uses it performance great because it will often do an allocation and copy out the chunk of the string into a new string in order to do it.
Oh, that's a different question.
It's still not that big of a deal, though. I mean, in Python terms, it's not a big cost. The bigger costs are when you have non-constant access time on something that is large.
Yeah.
So until you're dealing with large strings, or until you're really, really in a hot loop, almost none of this actually matters, I would say. So if you're not doing
in those large strings, hot loops all the time.
Yes, well, H2O was a hot loop on a large string, so you get what you pay for.
So was the DB company.
Right, exactly. 2 excellent examples. Yeah.
Fine.
But I think to Aaron's earlier question, it was basically, can't I translate this stream of variable length data into a stream of T and then operate on the stream of T? And yes, that's usually how you would do it. The Julia database example is a great example of where you explicitly avoid that by first converting the inputs to bytes and then looking for the bytes in the underlying byte data structure, right? But that's a very purposeful optimization.
A good exploration is to get some language support to pass a function to the for loop. That function, be it whatever, be it a run length encoding, that would turn the bytes into T, and you have to get a language support for the keywords. For the by the way, I'm iterating and I'm passing this function to make it a T. You can achieve this, of course, if you have a view and you have an iterator of T that's already knows how to group the bytes into a type.
So last week, somebody had some paper on standard template library design, and the nature of iterators I thought was pretty sane. Iterators that only started at 0 versus iterators that start anywhere, and iterators that let you run off the end by exactly 1 or not, and iterators that did random access or not.
And how you pass them around. I've seen C libraries that are like, here is the version of the function that takes the raw bytes, and here's the version of the function that takes the slice object over the raw object, and here's the version that takes the iterator over the slice object over the raw object. And it's like, do I need 3 versions of this function? Could I get the API right so that if I can pass you an array or a slice of an array or an iterator over an array and not have that be 3 different functions?
I think the C issue is the truly 0 as opposed to minimal overhead. if I have a large array I'm handing around as a slice sometimes, the slice requires the bounds in the large array.
Yeah, slice implies indirection. You're going to take a pointer chase.
Yeah. And if I'm going to walk the slice and the slice is large, the indirection on the pointer didn't matter. It happened once per large array. No one cared. If, on the other hand, I'm stupidly slicing byte at a time out of the array, and every time I go to a byte, I first take a slice indirection, then I just doubled my overhead. And then it makes another difference that way. I think that's the motivation for C guys. I'm inclined to say there might be an array flavor and there might be a slice of an array which has an indirection. And I can't pass them both to the same library directly without having a further vcall on the main guy, the no indirection guy, to go figure out that he's not got a slice indirection, he's got the thing.
But it might be possible to let the compiler do that specialization without requiring the developer to think about the fact that there's two versions of the function.
Well, if I can get it out of the type system, I would say yes, because that says that I got the zero overhead flavor and it goes into the fast mode. The easy became fast. And if you said fast and you hand an indirection in to a hot loop lookup, then I would complain at you and tell you to go give me more information so I can tell that it's fast now. Or we both agree that I can't prove that I'm going to get rid of the indirection. And you have an indirection in your hot loop. Do you care? Tell me you don't care, or tell me more information so I can get rid of it. Yeah, fine.
I mean, it certainly sounds faster than the iterators I've seen from the Lisp world, where it's like, here's your element and here's the next function. And then you call that next function and hands you a tuple with the element and the next function.
Right.
And if you allocate every time you generate one of those next functions.
Yes. Boy, I worked really hard at C2 to get rid of the Java for loop syntax, the for, string colon array of strings. That turned out to be allocate an iterator object, and then secretly, and then load and store the index in and out of it, and using the index to look up in the array of chars, right? Well, that meant that every time you walked through the array, at minimum, you loaded a random value from memory, incremented it, and stored it back. And that blew range checks, and that blew everything on bounds of anything and whatever. And so I had to discover that it was the same iterator. Furthermore, you had several of them in this body function you're doing that. So I had to do alias analysis, escape analysis to decide that this iterator wasn't being confused with that iterator. So this iterator was in fact loading and storing the same thing, go around. Then I can do the loads and stores outside the loop. Oh, now I have an index variable. Now that I've got an index variable, finally, I can start doing range checks, range check elimination. So you had to stage them through. You started from a bad spot before you got to where you could do hard work to clean up the range checks to, turn it back into performance. It was way more work than anyone would have thunk. I guess they never asked me, so fine.
So how do you do that better in AA?
I don't know. I think that and ultimately it's just the minimum bounds on what you have to do. I don't understand.
Because I do still want my for each loop, particularly if my iterator can do some work for me, like unpacking the variable length objects in my delta encoded length encoded ints.
To pass a function along with the iterator in order to convert conveniently.
The iterator body has to be completely in line, including the next, and you're unpacking things. Also, the alias analysis has to tease apart this version of the iterator from that version of the iterator, including in nested loops where they're both simultaneously alive, but they're referring to different things.
I would just challenge the question about doing it better. I think it's a very reasonable approach. That's what the optimizing compilers can give us. We can build nice, clean abstractions and then let compilers clean it away and get to the underlying semantics. Yeah. So, I think it can be done differently, but I think it's a reasonable approach.
Yeah, optimizer's got it. It does. So since it does, let it go and just now let's work on the implementer to do this minimum level of implementation. There's a new expected level of what you think a language should do. And that's fair.
Yeah. Are you thinking of supporting infinite data types, like infinite length data types? Like stream.
I'm planning to hand out true closures, and you can make a generator, and that's a stream, and then there you go.
Yeah.
So there won't be any special language support for it.
But your sort of standard library wouldn't sort of treat those out similarly.
That's a different question.
Yeah.
There's a language
4D in digits of pi.
and right. Yeah. And then there's what you do with a standard library. And then there's what other people like to add into a standard library. You know, Java standard library has grown enormously over the years.
Yeah.
Streams got added. I don't need to plan on streams or not the streams right now.
Yeah. Okay. Yeah.
Did anyone
Well,
look at
you know-
Yorick's link?
Oh,
Coming back to the Lisp iterator thing briefly, what they did in Clojure, they added this a little bit later on in the language, is they did this chunked iterator. So you still have that same structure where you have a function that gives you the next piece, but it's not the next element. I think they take 20 or 30 pieces or something like that, and they do a chunk, and then they can do sort of more efficient work in those chunks.
mini batching,
It seemed to be
H2O.
a pretty decent performance improvement when they did
Oh
that.
yeah. Oh yeah. Oh yeah. That's H2O. Mini batched on more than 20 or 30, but yeah.
Yeah.
Huh.
Yeah, you can choose your chunk size if you implement your own. They give you the tools to do it, but not many people seem to know how that piece works, so nobody does that.
I'll have to read this offline there, York. That looks long and crazy looking.
It's basically about these differences between bytes, code points, glyphs, etc.
Yeah.
This is what with Inco, I initially sort of started with the usual approach where you have like you can get a byte out of a string, and then you can get like the number of characters or the number of bytes. But they end up with these confusing naming conventions, because do you call the thing to get the number of characters length or something else? Or what do you call the thing to get the size? So you end up with these things with some language you might be like, oh, length gets the number of glyphs or code points even. But size gets you the number of bytes.
I have a strong take on it already.
Also, I took the approach where string doesn't define a length method. There's a size method, which returns the size in bytes, as you would probably expect from that name. And if you wanted the number of Unicode glyphs, specifically graphene clusters, that's a terrible name, so I'll just call them glyphs. There's a method called characters, which returns an iterator over the characters, and then to get the length, you have to do something like string.characters.length or count, or whatever I called it. But that involves you actually having to iterate over it and having to count the number of glyphs there are. And that's a deliberate choice so that it's more explicit that, hey, this is a it's not a like a fixed time computation. Depends on the number of one number of glyphs, and two the version of your Unicode data set.
Yeah. So my take on this.
And then I also made the decision like you can index a string into a byte, but the method is specifically called byte. There's no like flat bracket indexing or something, so you know, hey, we are actually getting a byte.
Yeah.
There's no way of indexing it into a code point or a glyph, because again, that will be a constant time operation. You'd have to use iterators for that. Just say, oh, give me the iterator over the characters glyphs, and then skip the first 5. And in terms of like indexing views, I think the only sort of portable way of indexing a string is by bytes, because both code points and graphene clusters, they can change based on the Unicode version that you're using. I think specifically in a more recent version, there's some funny stuff around emoji where they added those combinators, so you can have like a character with a brown blah, and there's some changes there where based on the Unicode version, that's what this article was about. I believe the number of graphene clusters can change, because they've combined them. So now they treat what used to be 2 clusters as one, something like that. And so basically, if you ever have a piece of text and you want to sort of, I don't know, let's say highlight a particular range in that, use the byte range. Don't do like grapheme clusters or Unicode points, because assuming the string doesn't change, you can determine the byte range from these glyphs, for example, and the byte range will always be valid.
So my theory here is that I'm going to say there's different views over the data, and if you have an old school string view, then it has a length in bytes, and if you have a Unicode whatever view, you get a length in however you're counting. You're counting in code points or graphemes, you get a different count. And internally, that Unicode view can cache. It has to compute it once though, but he can cache and deliver the answer faster next go round. And in fact, he could cache all the points where things got weird on your counting and have a sort of incrementally larger extra amount of data that scales the size of the string, but lets you now get to constant time lookups via double indirection once to get the offsets to whatever, and then once more to get the actual data. Yeah. But I think I'll have a length, and I'm going to call it the pound signs above the 3, shifted 3. That'll be my length call, but it'll change semantics according to whether you're an old school string or you're a Unicode this string or a grapheme cluster that string.
Yeah, I think that when I was implementing string stuff, fortunately, most of the sort of standard library functionality you would have can do everything at the byte level. So things like substring matching, those sort of things you can all do at the byte level, assuming both your strings, assuming they're valid, UTF-8 already.
Yeah, it was the failure of Julia, is I couldn't get to the byte level without basically rewriting my own string library.
Right, but so in case of Inco, for example, things like does this string start with this other string? Because it demands strings are already valid UTF-8, you can just do a byte comparison basically.
But aren't there things that are explicitly unordered?
In the Unicode land? What do you mean by unordered?
That a white man face palming is the same as man face palming white.
Oh, if I'm doing a match, you're saying if I have
I think the combiner characters are explicitly unordered. What order you
combinators? You're saying the equality check for 2 UTF strings isn't just a simple bytes or bytes.
Yeah, you have to canonical.
Yeah, is A with an umlaut different than an umlaut with an A?
Yeah, okay. Sounds like the answer is no, you have to do something. Yeah. And that another good expensive thing to go do with Unicode things. Fine.
So the solution here would just be use UTF-32 because then I think everything's just one index.
No, I mean that's the problem, is that you still have to combine them to make emojis, for example, and in certain languages they don't have a code point for the fully combined things, so you may still have, even with just printed characters as opposed to emojis or something silly, you may still have a 5-character, I'm sorry, I'm not going to use the word character, a 5 code point grapheme.
Right, so I think, I don't know if 32 bits was enough, but let's say we create a UTF-64. In theory, you have so many code points that all these combinators, they could all just be a unique one. So you don't have man with hat and brown skin tone. That's just one point.
And we also have backwards compatibility, which is the other bitch with
you basically don't want anything other than UTF-8 anyway.
I'm reminded of going through the ASCII with control characters string data versus ASCII without control characters on an old school green screen, where you could just throw characters and they would say ABC, except I would carriage turn, new line, vertical tab, you know, go to the top left corner and do something else. And it was just like people complained all the time about embedded control characters, and they didn't work on teletypes with paper and all this kind of shit. This is like a similar operation going on here. There's all these extra embedded things that mean something weird and bizarre, and they're changing all my strings around. Oh, here's the XKCD now. I'd go look at this one here. Uh-oh. Yeah, exactly. Yep. That would be why I'm going to punt to the library, and then it's future Cliff's library design problem, which maybe I can punt to somebody else and have it their problem instead.
Could you just for the audio record, what question are you answering?
Me?
Yeah.
How do you handle UTF-8 code points and graphemes in a sane language design? And the answer is it's not the language, it's the library. So the language is going to ignore it. And then I'm going to punt to the library. This is still a thing that in my eye is mutating rapidly, faster than any language typically mutates. So I don't think it can be in a language. Language will never catch up.
Do people have opinions on the general rule of if it could be in the libraries, you should push it into the libraries and make the language simpler?
I'm pretty strongly there.
I mean, Scheme was definitely like put everything in the libraries.
Yeah.
Like if you're going for like an embedded thing where it has to be as small as possible, then probably you'd be more inclined to put things in libraries. But I think if you're building a more general purpose language, it should at the very least go in the standard library. To me, language library is kind of the same. But I think the general rule of thumb is if like 90% of the people need it, it should be, let's say at least in your standard library. But even there, it kind of depends. Like there are things like, oh, should your standard library have an HTTP client, for example? I'm personally of the opinion yes, because otherwise you will end up with 15 competing HTTP libraries and they all kind of do the same thing, but like not quite, so people don't know which one to use. So you end up with like 4 different HTTP clients in one project because you decide to use A, but some dependency deep down uses B and so on. I'm not making this up, by the way. At least in Ruby, these are unfortunately real problems. I think another version of this you have in Rust. I think they made the mistake where they made this sort of async versus synchronous. So like the language has sort of foundations for it, but it doesn't provide an executor, for example. It just provides some sort of basic types and some compiler, and that's it.
Why do you consider a failure in design?
Well, so in this case, what you end up with is that the dominant library for doing async in Rust is Tokyo.
Tokyo, yeah.
But there are alternatives, so like async standard and small and a couple of others probably. But so you end up with this problem where these libraries are not compatible. So if I build some sort of a network I/O thing and I use Tokyo, chances are it won't work if somebody uses async standard, for example. Now there's been some efforts to like fix that, but my point is kind of like that is, at least to me, such a fundamental thing. The language should have done that. There should not be the debate, oh, which executor should I use? It should be like, no, there's just one. That's it. The language does offer a default one and then says, hey, if you want a different one, you can do it, but
my hunch, they didn't go this route because you can provide many execution strategies and you cannot pick the right one in, let's say, free for all.
Yeah, that's kind of where I disagree. That's where I feel, and this is obviously different languages take different approaches, different people take different approaches.
I want to point out, Matt put some comments in chat. of something far simpler than an HTTP library that was having issues being put into a library. Like pattern matching in the library was an issue? Oh, pattern matching in the language.
That's probably not so.
That's probably not a library thing.
This is like I understand it. It's like your library becomes your interface in order to align all of the code written at least at some base level to match up to a lineup. And at one point, it caused flexibility for the language for the new libraries. At the other point, it makes sure that they work together at some level. It's like the kernel and the kernel modules, for example. What do you want as a base? I know it's there, and when I search it, I will find it for sure. And what is a library? When I want the flexibility to swap out some parts of the kernel I don't want, but I cannot rely on this part on 100%.
Right. So that at the end of the day, that decision is arbitrary. So people take different choices. I think to highlight the Rust example there, it's not so much the problem that they didn't include it. It's that they kind of built this idea. So let's call it a framework for doing async, under the assumption that it's great that you can have your own executor, it gives you flexibility, blah blah blah. But with a lot of these decisions, what you see is that 9 out of 10 times people will just pick one of the solutions and stick with it. So in case of Rust, what happens is people pick Tokyo because historically
it's the first framework. It's the first framework to be around.
And so that's where most of the interest is. And then you kind of end up with this question like, okay, if let's say 9 out of 10 people pick Tokyo, what's the point of that being a third-party library? Essentially, why not bake it into the language and
well,
make it into the standard library, not the language.
Yeah. So that's what I mean. Like not in terms of like you add keywords or something now in your standard library.
Yeah. They can just
of course,
wait.
there's arguments against it, like now they need to maintain more and blah blah blah. So that's kind of where the decision is arbitrary. I personally lean more on the side of more in the standard library and less in third-party dependencies.
That would put pressure on them to pick what is the right one. And if it's not
a bunch of these new language guys get a repo of whatever. People handed you library variant things. Here's a library, here's a module to do X. And then there's a curated list from amongst those that says somebody's looked at the 15 HTTP clients and said, actually, we like X one, and we did a little cleanup on it. And now this is our, here's all the rest of them that are available. And here's the one that we like. And the short.
Yeah, I mean, that's what Java did with the date class, right?
Did they actually do that? I mean, the date was like horrific. And then people just went to Joda time and walked away.
Yeah, I thought they basically
Yoda time now has a copy of Yoda time in the JDK as part of Java.
Yes, I knew that it had eventually got there.
I do like the idea of small language, big standard library.
But for backwards compatibility, months are still 0 based and everything else is still. Wait, did I get that backwards?
Wait, in Joda time or in Java date?
Java date.
Oh, don't even.
Which is
talk
also
about
Java SQL date.
Oh,
which is,
Jesus! I took the Java date things in H2O as the first cut and ran them in parallel, and I got all the exceptions they talk about plus like 8 more that were not mentioned anywhere. If you just use parallel date conversions, I got Julian calendar exploded exception, and I don't know, fucking endless numbers of weird. The dates were so broken for any kind of parallel whatever consumption, like the standard using them the proper. This is supposed to be multi-thread safe or not, just ridiculous. So we switched to Joda time and never looked back.
So all that date stuff came from, if I remember correctly, it came from Taligent.
I haven't heard that name in a long time. Is that like an HP spinoff or something? Where did that come from?
It was an acquisition by IBM, but I think it actually originally came out of someone who left Apple back in the
Okay.
80s.
Yeah, it could have been. Fine.
So
I mean, it was a lot of work to make that time shit do something useful, no question. I mean, somebody put a lot of effort into that. I get it, but it needed another pass, and Joda got it right. Fine.
Yeah, I'm a big fan of if the old thing is terrible, sometimes it's easier to just make a new thing than fix the old thing.
Yeah.
You know, there's a bunch of early games in Java that wanted events to happen somewhat rarely. So they would call java.util.random until it gave you the same number twice in a row. And now they can't fix the fact that java.util.random occasionally gives the same thing twice in a row because it breaks old Java games. They just say, no, use java.cryptographic.random if you want an actually random number. Java.util.random, whatever,
Oh, it's
1 in
bad.
2 to the 16 times gives you the same thing twice in a row.
That was my first Twitter tweet was for I equals 0, I less than 1,000, I plus sum plus equal random of 2. And sum the numbers between 0 and 1 1,000 times. And what did you expect the answer to be? To give you a hint, it's not
50.
500.
I thought that was just a warm-up issue and that got better if your JVM had been on for a while.
No, this is a deterministic seed. You did new random, whatever, you got the default new random.
I expect the random to be 50% distribution.
Yes,
50%.
and you would be wrong. The answer
Right.
is until you had a few thousand seeds run through, it never really got very large. And so it was all 0.
yeah, I
First
don't think that's a
1,000 random
problem any longer.
I'm sorry?
I don't think that's a problem any longer.
No, it's not, but it definitely was for quite a while. I was wondering, then you said, hey, we couldn't change random. I'm wondering, no, I know they changed that one, but maybe they
Can't change the APIs.
Fine. All right. Broken libraries, they happen. We get it.
I mean, it's a good sign. If you have a bunch of legacy broken things that you can't fix, it means people are using your stuff.
Exactly what I was thinking, yes. Would I be so popular as people bitch and moan about the horrificness of my libraries?
You know what languages I don't complain about? The ones I don't use.
Don't use. Dun, dun, dun. Exactly. Well, okay, Klaus, what was MPSC? Multiprocessor.
Oh, sorry. Multi-producer, single consumer.
Okay.
Channel.
Yeah.
Or I mean, I just
Okay.
Rust has
Why did they
has started switching out stuff.
Yeah, why did they switch it out?
I think it's much more efficient than
Okay.
the
This is a
previous.
straight up performance issue.
Yeah.
Yeah, the standard that's called the old implementation because the new one will be the standard implementation.
You're not hearable, you're not audible, York?
Oh.
You're not on the mic. You're just
you're facing away from the mic.
No, it's not.
Is this better?
Yes.
Yeah.
Yep.
It was
Okay,
the
maybe I had
mic.
the sensitivity.
Now it's the microphone.
Yeah, the mic's very directional, and if your head's this way, it doesn't count.
Yeah, the setup with the arm is a little clunky, to be honest.
Yeah.
Yeah, the old implementation had some performance issues. I think specifically when you had a lot of threads involved, and it actually had some bugs or something where in like various specific cases it would do weird stuff and they couldn't quite fix it. So they're just like, yeah, we have Crossbeam that fixes all those problems. You know, let's just adopt that, be done with it. I think the only weird thing is they still kept it multiple producer, single consumer, even though the Crossbeam implementation that they're basing it on is a multi-producer, multi-consumer channel. I don't know if they had any plans on changing that. I think that's been kind of debated. That's kind of my issue there a bit with Rust, is that it kind of, I think it would benefit from somebody who's clearly in charge, basically, when it comes to decision making, because it's very distributed way of developing with people. You know, they come together and they discuss and they bike shit for like 5 years. Whereas I think for a lot of these, I think basically for any programming language, you really need somebody at the top who's like, no, we're doing it this way.
Damn it, man. Damn it.
Thank you for your feedback, but no.
Yep. Yeah, I saw MP when you said multiprocessor. That's always performance. Like you didn't go to multiple processors or multiple processes unless you had a performance problem. So those are supposed to be super efficient, and if they're not, then that's a hard fail. All right, what else? We can be done after an hour and a half too. The usual jack it up stories.
I mean, my always AA question of when Repl, but
oh yeah, so you missed the update. I've been making good progress on the test cases. Like the typing has like settled down. I'll probably push a big thing back to master. It won't run the Repl. It'll run 100 more tests, 200 more tests than it's run before. They're kind of marching along now as minor bug fixes for the incremental nature of things. And I had a big one just figured out yesterday, but it doesn't seem to be actually that big in the end. And, like on what it means to be typing correct or whatever. So things are coming together faster now. I'll probably at some point reach a point where I'll throw out a Repl that'll at least type expressions. When I run out of obvious things that just break in my short one-line test cases, I'll get to the break. And once I get something that has a Repl that doesn't break when people look cross-eyed at it, the execution after that is not long. That's a simple just walk the IR and execute it as a dumbass bad interpreter. And that'll open up a whole lot of like, hey, I can play around with it for a while things that I haven't, no one's coded in anger because you can't run anything. I get it. Fine.
Yeah, I think the hash map is still the largest program written in AA.
I'm sorry, what? Oh, yeah. Yes. Yeah. There's not a whole lot going on.
When AA is ready, maybe some members of the CCC design some libraries.
Well, yeah, there you go. First you'll code at it in anger and you'll break shit, and I'll be spending all my time doing bugs, which is fine. But my expectation is the first time somebody actually sits down and tries to do something, shit will break.
Of course.
Then you'll discover there's no debugger interface.
Of course.
That's when you realize that printf is way more complicated than you think it is.
Oh, yeah.
You start doing simple things and you're like, wait a second, why are all my numbers coming out in hex?
Right. Well, that's, Hello World is the most complicated programmer a newbie ever writes because it has a var call.
Printf in retrospect has to be one of the worst designs I've ever experienced. And I mean, I've used it for decades and decades, and I hate it more every time I use it. Just for the record.
So should we have the discussion of how you should template strings?
Function.
Yeah. There's a few million printf experts. Whether or not they want to be, there are a few million printf experts.
Yeah,
I would like to have some discussion on how to do template formatting in strings. I've seen Pythons go, and I've seen other people do things. I think there's some.
I kind of like the simple put braces in things in arbitrary code inside strings.
Yeah, right. Some escape character, and then arbitrary code. However that's done. Braces.
Yeah, yes. I think string interpolation is probably the the best way to go. I think all these compile time formatting approaches, they're nice for like simple cases, but they fall apart rather quickly, at least in terms of readability, when you want things like, I want to print a number and I want to pad it with this many zeros, and then I also want to pad it with some spaces, or when you start combining
things. Column. I want to make a 2D table printed. So I have to put spacing counts and width usages and stuff.
And so if you do that all with the like a compiled, I mean, you can do it. Like Rust, for example, supports it, but the syntax is like I never get the padding right, because what they do is, so if you want to print something, you have like the print line macro. You give your string, your template string basically, and then curly braces is basically a placeholder. And then in there, if you want to have it like debug printed, you do like a curly braces and then colon question mark inside of it. But if you want to have it left or right padded, it's a colon greater than or smaller than, and then the number of how many padding. And then I think if you want the padding character, it comes after that. I can't remember.
Right.
But I can never remember if I want to pad it on the left, do I have to use less than or greater than?
No.
Yorick,
What
you've
you already
convinced me
said
it
was
to be easier to write in assembly, right?
yeah, pretty much. You're right. The answer is
Because at least assembly only has like 600 ops now, right? Like,
I want to make a 2D table.
How much trouble could left padding cause?
Oh, geez.
Well, so my point more is there, like it's if you have string interpolation, you just interpolate your string. You do something like toString dot pad left, and you give the number of spaces or something, and that's it, right? It's a bit more verbose, but you're looking at like okay, this is what it does. Instead of
totally,
these,
why are there like? I mean, I maybe this exists. I've never seen it, but there are SQL builders. There are libraries that you can structure data and generate HTML strings. Why is there not like a structured data format thing that you just give it a simple data structure like many things like that for other domains, but it seems like I've never seen one that just like does normal string formatting in that way. Seems like it would be
like you give it an Excel spreadsheet.
Yeah. Like you give it a just the binary version of an Excel spreadsheet, whichever.
Well, HTML will do that.
Those text templates do somewhat similar things.
Yeah, but like for instance, I've seen a lot of simple HTML builders where it's like you give it an array of it's like a kind of command and then data and command, and it's sort of nested and all this stuff, and you can just represent all sorts of stuff, and it's quite clear, easy, and it formats nicely in your editor.
So printf makes an ASCII dump of whatever. And the usual formatting is because I want to make a table-like effect, 2D table.
Yeah.
You have a 2D table printer. So I think you go from simple string interpolation because I have a quick debugging print, I'm going to be done. And then I got complicated, switch over to here is the print tabulator, which I hand it something about how many columns and how wide the spacing is going to be. And he does the right thing after that.
Yeah, I use one of those all the time. Like I give it a list of maps and then a list of what order I want the columns in, and it prints them all out. It's not too smart, but it works okay.
And those float around. I do IR dumps, and the usual story is the first in columns are fixed width, so that it prints nicely, and then I have variable crap at the end. That's okay.
Yeah.
H2O, obviously, you did big data dumps of regions all the time as a debugger. So there was a debugging hook that said, take these columns and this range, and you got a 2D.
Yeah. Almost every 2D table printer I've used fails when one column's data is too long, or one cell has a giant blob of data, and it doesn't know how to wrap it.
You have to do something smart there. Yeah. You have to decide that you're going to chop it, or you're going to be variable, and this guy's going to blow out, and that's what it's going to do.
Yeah.
And there's also a lot of value in being able to delay. When Twitter switched from logging strings to structured logging, where it was like, okay, we're going to take the printf string, and then we're going to put the struct with all of the pieces in it. And we're going to take all of those until we get to like 64 megabytes, and then we're going to stick them in a Parquet file. And it turned out logs that were decomposed and in Parquet are way denser than the strings are.
Yes. Welcome to column compression. Works great.
Right, but I didn't think about columnar compression as the proper way to store logs until I saw it. And I was like, oh my God, our logs are the same log message 100,000 times. Of course, the columnar compression,
Yeah, exactly.
Dictionary encode the format strings, and the rest of it is nice columns.
That's
okay,
what
so you're halfway.
that kind of data.
You're halfway to where I was suggesting like 3 years ago when we had a conversation about stack traces. Because now, look at every stack trace and tell me Aaron is wrong.
Yeah, no. Stack traces have the same thing. There's a massive compression. If you're going to collect lots and lots, like say your JVM and you're doing random stack sampling and you're collecting them 1,000 times a second, for years on end or days on end, you get millions and billions of these
Arthur, you must have done something with that, right? Like some sort of compressed, deduped, whatever.
Can't think of anything from the top of my head.
I did it at Azul for a lot of that. I didn't go super far. The first compression was the return program counter could totally be indexed into the JVM structures to tell you everything about the function and where you were in it when you got called. So that was a short, quick peek into. And then, yeah, there was an accumulators afterwards that turned them into compressed versions. I kept a large count, and then as you fell off the end, I don't know if this is still there, I would throw them into the GIL 10A flavored power of 2 histogram collectors. So you got an infinite data stream of infinitely less precise, and the further back you went, history of where the stack traces went.
So I don't know if I've told you all my favorite string formatting story. This comes from when I was working at a web app firewall company. And it turned out that there was a popular Django middleware that would check the content type and say, oh, this is in fact not the content type that is on the allow list. I'm only accepting JSON and YAML and CSV or whatever. And it would send back this message that's like, hey, you gave me illegal content type this thing. And it managed to get the content type that was sent on the format side of a call to Python string format, which meant that if you sent a content type that included brace, arbitrary Python code, brace, it would get executed in your server and then hand you back the error message that said the arbitrary executions result in that spot. And this led to a number of our customer servers mining Monero.
About to say, oh, that sounds like security injection. Oh, Bitcoin miners, gotcha.
So yeah, you do have to be a little bit careful
tables.
with the arbitrary code in the format strings.
Long requests.
Yes. Wow, fine.
Yeah, maybe don't eval things that someone hands you over the internet. Just
Jeez.
No, it's fine. It was in the content type. Why would the content type attack you?
Oh, geez. I'm sorry, I'm reading the Discord chat on GCC COBOL. Matt, why are you looking at COBOL? Because it has strings. It has a nice string formatting strategy. Actually, COBOL has, you could argue a semi-sensible string formatting strategy. You can picture, quote, letters, dot, whatever.
just to be clear, all that COBOL is a string formatting language.
Not denying. They can do algebra with text. If sales
well formatted algebra with text, right?
Yes.
Exactly.
Yes. You can do simple expression math using but they have one other magical special power no one on the planet does, and that is being alive in the 60s. So there you go. Can't take that from them. All right.
COBOL 60?
If they weren't COBOL.
I don't know. Would you rather maintain a large COBOL system or a large awk system?
Oh, probably the large COBOL system will pay a lot better. Or I'll demand a lot more, and anyone who cares about COBOL will pay. Yeah. See, the awk system, we put together a bunch of hackers that does some really cool, interesting infrastructure that's totally required for running the country, but like no one will pay for it. Whereas, Goldman Sachs will say, oh my fucking God, we have to do something about this COBOL mess. And I'll say, that'll be 10,000 a day, and it'll probably take me 6 months. And they'll be like, oh, fuck you, here's your check. I'll be like, all right, here we go. Gold-plated turd shoveling, fine. Do it. Anything else? I'm going to wrap it. All right, till we meet again next week. Nice seeing you, class. Hope you make it next time.
Yep. Thanks for
Bye.
inviting me. See you.